So I guess I can kick this off. Unless Jessica, how you feeling over there? You ready to
Go
rock?
for it.
Okay, and then yeah, so I'm just gonna introduce everybody, or not everybody, but myself. My name is Ryan Robinson. I am the community associate at Altimetric Collider, and I'm super excited once again to be teaming up with Detroit Tech Watch. They always, Honorio, Mike, you all are always like just on the edge of like the cutting edge of technology, always bringing in cool people. So really, really, really appreciate that because you add to our community facing side of the company, which is Collider. But Altimetric Collider is a company in general that specializes in keeping our clients ahead of the curve and technical innovation. And myself and the community director, Jacob Smith, we are the Collider team that works with the community, and we try to gear all our talks towards tech professionals with interest in real life solutions and relevant things that are going on. So, Honorio, I'll let you take it away and introduce the awesome Jessitron.
Yeah, it's really a pleasure, honestly, to be able to welcome Jessica to our meetup because Jessica and I go way back. She came up here in 2012 for a conference I did over in Ann Arbor. We met each other then, and every time I talk to her, she drops some new knowledge on me, and it's like, wow, I just love talking to her because I get so much smarter when I'm around her. Not to oversell her or anything, but I think I've talked enough. I'm going to let her talk and just enjoy.
Okay.
Go ahead, Jessica. Take it away.
All right. Thanks, Honorio. Let me share screen on the iPad for slides. But this presentation is, I did a bunch of changes to this one yesterday, and I really want your input on what makes sense. I mean, this is a really small group, so this should hopefully be a lot of discussion. Questions and stuff, welcome. Very welcome. And opinions, if you want to disagree with me, that's always fun. Share content. Make it, okay, that says domain-driven design behind the sticky note. All right, this talk is about the one paradigm to rule them all, in my opinion, because I've done a lot of exploring of languages and programming paradigms and movements. I've gone from C and Java to Scala and Clojure and Ruby and Elm and JavaScript and TypeScript, and I did some I don't know, enough languages. And I've given talks on Elixir. Does that count? And also DevOps and Agile and object-oriented and functional. And so many of these things, I find all the essence of them in this one programming movement, whatever paradigm, domain-driven design. This book was written 15 years ago by Eric Evans. And it kind of anticipated a lot of things that we've learned since then, but also no other set of programming advice that I've ever found contains the core element of domain-driven design. And I think that's really what sets it apart. It leads to a bunch of the other things that the other paradigms have kind of picked up on, but that core element applies not just to programming but also to life. So this talk, I'm going to explain domain-driven design through the lenses of various other movements and paradigms. And then I'm going to talk about that core element of domain-driven design, the language, and find that in modern philosophy. So that'll be different.
Cool.
Yeah, we'll see how it goes. We'll see what you think. So let's start with Wardley mapping. Okay, so Wardley mapping is a fairly recent movement in software started by Simon Wardley, but you can find more at learnwardleymapping.com. And Wardley mapping says it's a way of talking about strategy. And the important part is the talking. the process of drawing the Wardley map brings out a lot of what various people know and helps us talk about what we're building. And the draw white, the practice of Wardley mapping, you start with like a customer who is getting value, and then you like draw the value chain in the software. So say there's some shipping company and they have customers who want to ship stuff in containers across the ocean. So what the customer needs is to get their stuff shipped. So they call into customer support. So we need a customer support call center, and also they're going to interact with some software. So we need customer support software. That software needs itinerary tracking, which in turn maybe needs, I don't know, container capacity, a lot of other things, but for the purposes of this. And it needs routing. Routing needs graph traversal to be able to do the traveling salesman problem and find a good route. Oh, also we need invoicing and itinerary tracking. Well, they both need a database. So these are some examples of following the value chain down through the software. And these little node thingies are called capabilities. When you're doing Wardley mapping, you don't put the name of your system there. You don't put Scopus if that's the name of your itinerary tracking. You don't put QuickBooks if that's the name of your invoicing. You put what you need out of it, the point. Your database may be Oracle or Postgres. What matters is that you need a database because these are capabilities that your business requires. And
Jessica, are those capabilities along the same line as like user stories?
I would say they're broader than user stories.
Okay.
User stories are usually like one path through a capability. I don't know. It depends how you write your user stories too. User stories are different at different places.
Okay.
But I mean, really, if you like worked on the customer support app, you would zoom way the heck in and get a lot more detail on what is in customer support. But if you're not, if you're looking at very high level strategy, you might lump that into a single capability, customer support. That's really a lot of things. And that's normal. There's various levels of zoom.
Okay, I think I see what you're talking about.
Okay, a capability is bigger than a feature. It's like a whole, I mean, itinerary tracking has lots of different user stories in it. You have schedule a route for a night for a cargo, and then you might have cancel, and you're going to need reroute if it misses the boat or something. And so there's going to be a lot of different things inside itinerary tracking, but they group together in the same domain. The domain of establishing and tracking itineraries, which uses routing in this case. The itinerary tracking system doesn't do the routing because that's a particularly hard problem. It calls out to another system to do that. It's like that is a distinct capability that's rather different from itinerary tracking. I mean, itinerary tracking, you need a database, but there's not a lot of worry about performance. Routing could care a lot about performance because it's an NP hard problem. But I'm glad you asked the question, Honorio, because thinking about your system in terms of capabilities is a big thing that comes from Wardley mapping. It's a really valuable thing that comes from Wardley mapping. And it also comes from domain-driven design in the sense of recognizing that each piece of software has different domains. It's in the name, domain-driven design. Each of these capabilities might be a separate domain or not. Maybe itinerary tracking and container capacity are the same. And then routing is is a particular domain and graph traversal is a particular domain. Maybe invoicing is a nice one, but you might group some of these together, but in general, a capability is in a domain if you use the same language to talk about it. So this gets into one of the three, I made these up, but in my opinion, one of the three crucial points of domain design is that you divide your software system at a high level into bounded contexts. Would you pick that thing? Miro, let me do, oh, I need the arrow tool. Ah, there we go. All right. And these bounded contexts, which typically you put around capabilities, have their own language. Roughly, these correspond to a team and a subsystem and maybe a service, depending on how you have your stuff divided up. But the crucial point from domain-driven design perspective is not whether they have a particular team or a particular architecture. It's the language that they use. And this is a domain language. So we're talking about itineraries, stops, legs, cargo. Itineraries should be connected. We may talk about cost limits and arrival dates and restricted cargo and stuff like that. There is a language around this particular domain and this particular capability. And domain-driven design is very explicit about we spend time developing that language and defining terms and using them carefully, both with our mouths and in documentation and in the code. That's the essence. And this explains to me why naming is hard. Naming is hard. It's one of the two hardest problems in computer science.
That's a fact.
That's a fact. Everybody knows that, right? That and cache validation, invalidation, and sometimes off by one errors. But naming really is hard. Do you ever, like, you're coding along and you want to do a thing and you just get stuck and you're like, what do we call this? And you make up something. I've realized since learning about domain-driven design that naming really is a hard problem. And when we get stuck on it, that's a sign that we need an understanding of the domain language, typically. And if you've put that thought in up front, then naming things becomes much easier because you've established what you call these things and you can be careful. Yeah.
Hey, Jessica, when you're talking about capabilities, could you almost partition on like a buy versus build like decision?
Oh, absolutely. Yeah, we're going to get to that. Yep.
Oh, okay. Sorry.
Yep.
Didn't mean to steal the point later.
You're getting it. Yes. That is totally one of the things you do. I want to come back around to the Wardley map slide. We're going to do exactly that. Great. Okay. So naming is hard because until you recognize that and use that to sharpen your knowledge of the domain by building a language. Usually bounded contexts have their own team. And if they don't, that's like a smell. Because Conway's law is one of the laws of physics of software, really. You need a particular team with a particular part of the system because they need to share that language with the code. And that reminds me of product teams. So lately, this is certainly a thing at Ford. It seems to be the next big thing. After Agile, we have product-driven organization or project to products. Or generally, we should have product teams that like have responsibility for their own work, and autonomy and blah, 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 blah. And the important point here that is also shared with DDD is that software teams, okay, our job is not to implement user stories. Our job is not to write features. Our job is to supply a capability to the organization. We do that by operating software. The writing the software is only a prerequisite to operating the software and then continually improving it. But if at work, and this is still the normal case, but what we're moving away from is feature factories, is your job is to churn out code and make it do something different all the time without knowing why. A product team knows why. They know why they're doing it. They know what success means, and they know how to find that out. Now, most of our teams are a long way from there, but that, unless you work in a startup, but that is like the next direction of the industry after Agile. Yeah. So think about your job as supplying capabilities, and how would that make your work different?
Yeah, there was something I was reading, and they were talking about, and maybe you saw this too, Jessica. They were mentioning that too often we think of the software we create as being a big bang. We're going to release version 1.0 and we're done.
Right, as if there's such a thing as done. Well, there is such a thing as done. Exactly. It's out of production.
Yeah, exactly.
Yeah, it's shut down. Yeah.
That too many of us don't take the view that, look, once you get 1.0 out the door, you've got to maintain it. You've got to add new capabilities.
Oh, yeah, that's when it gets hard, after it's in production, because both supplying that capability and improving it is a lot harder than building it in the first place. Yeah. So that's the thing. And I also find this in the book Team Topologies. Highly recommend this book. It's really good. It describes, there it is, we'll make it bigger. It describes patterns for organizing teams, many of which are like value stream teams. These are the product teams that are supplying capabilities to either internal to the organization or directly to customers. But there's also like 3 other team patterns in there. The beautiful thing about this book is that it recognizes the reason we break into teams at all, and the reason we have more than one team instead of just a zillion, or instead of one team for the whole software system. We're not feature factories. So the reason one team can't support a ridiculous amount of software, including if they built it, is not as much what we can do. That's not our limitation. Okay, sometimes enough process is imposed that is our limitation. But given the opportunity to do enough automation and stuff, we can get it to where it's not about what we can do. What it is about is our cognitive load, is how much we can know. And that language comes in again, and the part where each capability has a different language. Routing has a different language than itinerary tracking, has a different language than customer support. There's commonalities, but those will just fool you.
Overloading of terms is a big problem.
Yeah. If you really want to hear me rant, get me on the idea of a canonical customer.
Yeah.
Words naturally mean different things in different contexts, and that's important. And that ambiguity is essential to the English language. But we've got in code, we have to remove that ambiguity. Code has to be super specific. So what we do is narrow the context, and each word has a specific definition within the context. More on that later. In the meantime, what I love of Team Topologies, because it recognizes the cognitive load is our limitation. That's why we break into teams. It's why we need boundaries, because we can only understand so much. And then Team Topologies makes it names like 4 different kinds of teams. There's like the platform team, and the value drop team, and the I forgot the other 2. But puts explicit relationships between them too. So maybe the where's my example? Oh, I forgot to draw some bounded context. Let's draw these bounded contexts. Maybe the customer support team and the itinerary tracking team work together really closely. And meanwhile, the routing team also handles the graph traversal, and their main language is around nodes and edges and graphy terms. But the, whoops, no, that's not, this goes there. What I find in both team topologies and domain-driven design is the bit about make these relationships explicit. So maybe this one is a partnership, but in this one, routing says what you need to send, and itinerary tracking team is a customer of the routing team. The routing team wants to know what their customer wants, but they're going to send, they have control of the language of what is sent. And that's significant. Invoicing may have its own language, and so you have to do some translation there. You can be explicit about these relationships, and then you can notice each of these lines between bounded contexts. Now here, I'm not drawing, this is not a data flow diagram. This is not a services architecture diagram. This is specifically a diagram of the different languages that reside in different bounded contexts. And when the software, the itinerary tracking software, calls to the routing service, it's speaking some language. And what language is that? Who determines what language is that? Well, in this case, it's the language of the routing service. The routing service determines that language. And here the invoicing service determines that language. And here they work on it together. And this tracks the power relationships between the different teams. And this is where domain-driven design reminds me of feminism, or specifically feminist thought. Because when I read that, then I learn about how to acknowledge power differentials, how to see them and the effects that they have. So in this case, we have this Blotus system that talks to this magic system. And in domain-driven design, you label them upstream, downstream. I should have done that down here. Upstream, downstream, upstream, downstream. Not in the direction of data flow. It doesn't matter which direction data flows. What matters is who controls the language. So upstream is who controls the language. And, so they get their water. If they were a city, they'd get their water from the river, and then they dump their sewage in the river. And the downstream city, magic in this case, has to deal with that crap. So the upstream one is the one with more power in this relationship. And then in this case, the magic system has written what DDD calls an anti-corruption layer to do the translation, so that the language and the data format that Blotus chooses doesn't corrupt their careful domain language that they have inside, that they use inside. So these explicit.
So the upstream sets the terminology, and the downstream has just got to deal with it.
Yep.
And make the translation between like the upstream's terminology, if it's different, and their own internal terminology.
Mm-hmm.
Gotcha.
Yeah. So who controls this language is who has more power. And an interesting thing here is the more agile lowercase a, the more flexible the team and the software, the less power that group has. Because if Blotus is the big legacy system that everyone is afraid to change, then you take what you get and you make it work for you.
That makes a lot of sense.
Yeah, yeah. So in this case, the powerful one is the slow one, interestingly. Right. So feminism and domain-driven design both acknowledge power differentials in the relationships. Okay. Finally, let me pick this. Oh, I need the arrow tool. There it is. Delete. You hope that each bounded context is its own deployable unit or units. There could be a couple services in there. It doesn't matter. But this is where domain-driven design overlaps with microservices, because microservices also give us a way to enforce boundaries. When the book was written, when domain-driven design was written 15 years ago, service-oriented architecture was kind of new. Microservices was not a thing. So typically, a bounded context team would produce a library, several modules that all get compiled into one big application. Now we have the choice of each bounded context maintaining its own service and its own data or services. It doesn't matter. And that's great because it makes those boundaries really clear. It's not possible for the customer service app to reach deep into the inventory trackings database and just pull out what it needs without going through the proper APIs that enforce invariance and keep the data consistent. Yeah. So if you don't have separate deployment units, you at least have separate transaction boundaries at the bounded contexts. And the beauty of that is that it decouples rates of change. This is how you let teams get anything done at all. You have strong boundaries between them, and you tell them that you can change when you change. That's up to you. And you can change when you change. That's up to you. When you have, oh, well, we can't release the new front end code until the back end is ready. That's when it becomes a coordination problem. And as it gets bigger, it just gets harder and harder. And it becomes statistically unlikely to have a successful deployment when things are coupled.
Yeah, that's always true. You want to scale things, you do not want coupling. You want to avoid coupling at all.
And you're like, well, but some deployments go smoothly. Those are statistically unlikely, but it happens. So you're just like, oh, but if we just get better at it and do more coordination, then it'll be smooth. And you're wrong. No, this is not a possible problem to solve.
Yes.
So you need to decouple those rates of change between bounded contexts. I don't care how many microservices you have in each one. And so when you see bounded contexts having their own teams and their own deployment units, that's a sign of health. When they don't coincide, then you're like, ooh, that might not be healthy. That's an area where we're probably going to have problems. This explains to me, or DDD anyway, explains to me what the dry principle is. There's a lot of arguments over dry lately, thank goodness. The principle of don't repeat yourself, people obsess over this. They just hate duplicated code and they want to remove it and put it in a utility function. Fortunately, that doesn't work as well across microservices unless you put it in a library, which is even worse. There's a limit. There's a limit to how hard we should try to remove duplicated code, because every time you remove duplicated code, you create a dependency that wasn't there before. If that's a business dependency, if this is like, how heavy is this container? And I should be able, and if that updates anywhere, it should update everywhere in the system. Okay, make it a service or whatever. That's code to remove duplication from. But if it's left padding a string with spaces, no. Just have a function in every different bounded context. And then it's one team that maintains it and it's fine. You're not creating extra coupling between bounded contexts by removing that duplication.
Yeah, that's an interesting point, Jessica, because it's been my observation lately that, there's a trade-off there. Yes, I want to decouple things, but by decoupling things, like you say, you can introduce, like saying, I'm not going to repeat this code. It's only going to live in this one place, and you can introduce unintentional coupling.
Yeah. Yeah. And if it's incidental coupling, it's really bad. But also keep in mind that the word itinerary means something different in customer support than it does in inventory or itinerary tracking. In customer support, I don't know, they're looking at it from the perspective of what do I tell to a customer, whereas in itinerary tracking, it might need a whole history. It's a different thing. And as soon as you start trying to remove duplication between those, you conflate those. And then your itinerary object has 20 methods, 12 of which are used here and 11 of which are used here. And that's a mess. So duplication can really be our friend in clarifying exactly what we mean and making it possible to change code. Because that's really what all of this is about. It's how do we write code that not only runs, but supports change? Because that's how our business can learn.
I tell you, it's not exactly the same thing as what you're going for, but one of the reasons I think that people need to reevaluate that whole DRY thing is if you look at Erlang in their VM, like one of the things they do is they do not share variables between processes. They copy the whole shooting match between one process and another. And at first that seems like that's so inefficient. And then you think, wait a minute, when that process is done, it can wipe everything. It doesn't have to worry about this variable being used by somebody else.
Right.
So in a sense, that's kind of, this kind of, again, don't repeat yourself is good, but within reason.
Right. Right. Yeah. Within your team, within your bounded context, then it's important. Speaking of importance, something else that, undo, get back down there. There we go. Another thing that Wardley mapping and domain-driven design have in common is recognizing that not all of these capabilities they're all necessary, but some of them are more critical than others. Some of them we need to be flexible on. So the horizontal, the vertical axis in the Wardley map is value chain, how close to the customer is it? It goes down as it gets farther from the customer. The horizontal axis is more interesting, and that is how established is this capability? Not in your company, in the world, in the industry. So like database, way over to the right, because that's a very solid established thing. You buy a database, you do not build one. That would be ridiculous for most businesses. It's a utility, kind of like electricity and compute when it's on the cloud. And then you've got stuff that's pretty established. Graph traversal, you're going to find a good library that has been like performance improved by various people's PhD thesis work for that. You're not going to do your own graph traversal optimization. Invoicing, everybody needs it. You can buy that. Buy it. Buy it, and the language of the invoicing software, use its language, at least for the interface, because there's reasons that language has been evolved over time to be effective at invoicing. And then there's like the custom software that you write in-house, and that's the left half of the Wardley map. But some of that, come here. There we go. Some of that is more dynamic than others. You need customer support software, but if it's not the most brilliant customer support software ever, that's okay. It needs to be adequate. Inventory tracking had better be solid, but it's not where we're innovating. That stuff way over on the left is where we're innovating. So, and what determines that is business strategy. The strategy of this particular shipping business is it's really good at finding the cheapest routes that other companies sometimes miss. And it does that by translating a bunch of, this isn't on here, but a bunch of feeds from different shippers, different people we can hire to ship a container, into a graph and using optimized graph traversals. Cool. But the thing is, because that's our strategy, we need to have a lowercase a agile team working on that can make change quickly and test stuff. That's where we're experimenting. That's where we're innovating. That's over in Genesis. And you don't have very many things over there. This maps directly to the strategic design chapters in DDD. Because those Genesis fields, that routing in our case, is what we call the core domain. Determined by business strategy, this is where we're really defining how our business works, and we're changing this and we're working on this, and we need to be really specific and have our best people on that. Your best developers, we don't need to be in infrastructure, we need to be in the core domain. And then there's all these other supporting domains that we need to work. And you know what? If these aren't the most agile teams, it's fine. As long as they can get the stuff done, it's fine. And then there's generic subdomains. And those are the ones that we can buy. Software as a service is a great, great thing. So in domain-driven design, you look at your bounded context, you look at the relationships between them, and you decide which are your core domain. And then you put a nice yellow, no, that's caps lock, yellow star on it. Please be yellow. Yellow. And that is your core domain. And that's where you put a lot of energy and you put more design effort in. And you try to make sure that there's one team, it has control over its deployments and stuff like that. At least you make sure that one has healthy relationships.
So that's where all the top flight developers should be deployed.
Yeah. Yeah. I mean, so like this is something that we as developers as a culture, I think, miss. Most developers, as we get more senior, we want to move into the more technical stuff. We get excited about the platforms and we want to go deeper into abstraction. I don't want to go deeper into abstraction. That's for the software as a service people. I just want to hire like cloud deployment. I want to go deep in the core domain of the business. One thing I love about software is that if we want, we can totally switch around domains. So I've worked in retail and telecom and insurance and finance and automotive. And I enjoy that. But if you want an advantage at a new job, look for one that's in an industry you've worked in before. Because learning a programming language is way the heck easier than learning the intricacies of the particular business domain you work in. You can't get that on Stack Overflow. You can't buy a book on it. Sometimes you can, like at Stripe, they sent us payment systems in the US, which was boring, but very useful to explain the rudiments of the domain. But the specifics of the business you work in, you'll never find anywhere except by working there. And that's where you get to be like a really impactful senior developer, staff engineer kind of thing, is understanding the domain. And you get that through, okay, so number 2, let me flip through here a bit. We looked at that and that and that and that.
Hey,
Bounded
Jessica, before I forget to ask, can you do us a little solid and send along a reading list when you're after this?
Sure. And I can send a link to this presentation. Whee!
Either way, because you're mentioning some great books that you're putting little bugs in my brain that I want to read those, and I want to make sure I don't forget them.
Cool. So far of the ones I've mentioned, Team Topologies, great. really gets at the essence of what makes software hard and how to organize teams.
Cool.
So the number 2 principle of domain-driven design, in my opinion, is that we develop a shared model, that is the design, in collaboration with domain experts, developers and domain experts. And together we create a model which represents a data design, among other things, and a language. The language is totally part of the model. And let's see what's next. This reminds me of XP. So I like to use XP now, like the original Extreme Programming, as a kind of, give me the pen, as a kind of lowercase a Agile, like the original intention of Agile. Some of that is out of date with respect to products, but the part where we work together with the business experts and to get immediate feedback and really collectively understand what we're doing, that's important. And it's at the center of domain-driven design too. Now notice sometimes in like the Agile Manifesto, they called these people customers. I'm not sure if that was in the manifesto, but certainly in a lot of the Agile implementations that I've seen, the business experts are customers in the sense that they tell you what to do and then you do it. And then they say, oh, no, I wanted the box over there. Oh, you should be able to click and see the tooltip too. Don't think that those people are your customers. Your customers are using the website. They're buying cars or whatever it is your company produces. They're using your company's software if this is like a customer facing tool. The business is part of your team. I mean, we're in this together. It's not the business and developers. The developers are also the business. Okay, so there's domain experts and there's developers, and those are different. If you can be both, you're amazingly valuable, but generally at least starts out with developers and domain experts being different. But we're working together to serve someone who is not, well, they might be employed in the company if it's an internal software, but the people using this software, not the people making the product plans. On the other hand, if all you want to do is, I don't know, is make your manager happy, then that may be different depending on where you are. But I personally am not satisfied calling anyone internal a customer unless I'm like an internal product team deliberately enabling other teams. Okay. That's what I have to say about that. Go away. The part of XP is test-driven development. And test-driven development has a lot of overlap with domain-driven design too. The big one being it drives you to understand what you're doing before you write the code. That's like a high bar, really. And this is one reason writing tests is really hard, because you really have to understand the intent of what you're doing. And then you have to put yourself in the shoes of a user of the API, a user of the function you're writing, or the API you're writing, or the method you're writing, whatever, before you dive in as an implementer. So it puts you in these dual roles, keeps you having dual perspectives, and that produces better implemented code, especially at the API level. So I like that. And then if you write the tests in the given, when, then format, then you're doing behavior-driven design, hopefully, or at least attempting to. And Daniel Turhurst-North came up with that one not too long after domain-driven design was published. And the big key here is that the model and the design activities of producing a model and a language are driven by concrete examples. So maybe, maybe you thought, okay, we have an itinerary. And an itinerary includes a bunch of stops. And then you get the use case of, oh, no, we need to reroute. Dallas has electricity shortages and we need to send this cargo through Chicago instead. And if this gets messy, trust me, it does. I don't want to go into detail of why. You might be like, oh, shoot. You know what? It would be a lot easier if our itinerary had legs corresponding to like each trip on a train instead of each city they stop in. Because if you cancel something, you cancel a leg. You don't need to cancel a whole stop sometimes. And then you're like, okay, that's a concrete example that drives us toward this design over here. Always concrete examples to drive the design. And you want the unhappy path, not just the happy path. You really want to get those domain experts to tell you stories of things that totally happen, but you wouldn't expect. Like overbooking. That's a non-happy path, and maybe you have backup legs, I don't know, to go with that. But you drive the model design with concrete examples, and that is also expressed in behavior-driven design. And another reason to write tests.
It's funny you mentioned about BDD, because lately I've been kind of like a little bit opposed to it, because to me it's throwing another layer of abstraction on top of things. And that's another layer where things can go wrong too.
I'm not opinionated on BDD. What I care about is those concrete examples.
Yeah.
That's.
I mean,
this
it's
is
the
the
given if
important
then
part.
when that they're using and tested my work, and it's like, okay, yet another layer that could potentially be wrong that I've got to look at when I've got to debug something. That's my biggest concern about it.
And if you're not using that layer, if that layer isn't adding value, for instance, like having non-developers who look at it and can read it and get value out of that, then don't do it.
Right.
Yeah.
And that's
a
what
lot
we're
of these
having
practices, from XP to TDD to BDD, I don't need to use the practice if I can get the essential benefit. And that's these post-its.
Good point.
And let's see, finally, this reminds the other thing that domain-driven design respects in this collaboration between domain experts and developers, and the code. The code is part of this collaboration too, thanks to our past selves who wrote it. We acknowledge the socio-technical system, that the code is part of this and the people are part of it. And we bring the domain experts and their knowledge into that. And that I find in DevOps. And acknowledging that this system is, I should probably move this over to the next section. It's not just us, and it's not just the code. It's us in combination with the code and everyone else who has knowledge that we need to do this well. Of course, I call them symmathesies, but I'll put that picture up later. Finally, the third pillar, in my opinion, of domain-driven design is that we use that language and the domain model that we've carefully designed in the code, also in documentation and also when we talk about it. But the hard part is getting it into the code. This means that we need some code that we can just express the domain model in and not have a bunch of implementation details like how to talk to Datadog, how to do database operations, how to do the logging, and the details of calling through to the invoicing service. all of those implementation details we want separate from our code that maximally expresses that domain knowledge that we've so carefully acquired in collaboration with the experts. And that gets to, in the book, Eric Evans talked about layered architecture. That's old. But hexagonal architecture, where you recognize that there are many interfaces to our code. So you might have here, you might have a customer UI. This is like the web page on the web. And you might have an admin UI. You have the database. You have, I don't know, logging. And then you have other systems. So here you might have the routing system and other dependencies. Alistair Coburn named this hexagonal architecture, but it doesn't actually matter how many sides it has. The point is it's more than two. You keep your precious domain code with its careful language in the center, and then you write adapters at all the interfaces. So that your domain code is never tied to the language that, I don't know, the invoicing system requires. You don't depend directly on the Stripe API. You depend on an adapter that happens to call out to Stripe to make payments, something like that. It's also, so that's why it's also called ports and adapters. That's crucial to getting that isolation so that you can keep your language consistent and expressive in the code, so that you can write things like, let's see, reroute, itinerary, and then whatever rerouting specification you need. And you can look at like itinerary dot, for instance, is connected. Is it a valid itinerary that, like, if you fly into Chicago, you leave Chicago, kind of thing. You can express these concepts in the important domain layer of the code. And then a lot of the book, the blue book about domain-driven design, all this strategic stuff, all the stuff I've already talked about, which is so crucial. Well, the first section anyway, is like way in the back of the book, but it's the most important part. When Eric Evans, he recommended to me, he's like, you can skip a lot of the code examples, read the strategic design stuff. That's actually the most important stuff. And it happens to be at the end of the book. All of the stuff in the book intertwines though. But 15 years ago, he also had to write a lot of instructions about how to keep this domain language consistent in the code. And within that center section of domain code, there's like a little list of things that you have in there. And this is entirely based on Java and object-oriented programming, because it was 2005. So he specifies various things. There's a couple others like factories and repositories that don't matter. But he divides the domain code into three different things. Value objects are the first one. And value objects are particularly lovely because they're immutable. And immutability of data is a big thing now. It is one of the two most important features of functional programming. Immutable data is incredibly valuable because, like Honorio pointed out in Erlang, if nobody else can change your data and nobody else can, or you just can't mess them up. You just can't interfere with each other as much if your data is immutable. And a chapter of the domain-driven design book is how to implement immutability when your language doesn't support it. And he brought out this really key principle way before it was the latest thing. Now Java has some immutability. You can declare things final at least. It has more support for that. And a lot of languages have native default to immutability, which is really good. And services then represent functions as first-class objects. So he recognized this early and says, okay, object-oriented programming, we can get these objects can really get out of hand. Here's one of the ways we keep them under control. Value objects, stuff like maybe a leg of an itinerary might be a value object. And when you cancel the leg from Chicago to New York, you just throw it away. You just throw that data away because whatever, it's a value object. We'll create a new one when we need it. Also, he incorporated this. This is like legit. Eric deliberately incorporated stuff from design by contract, including the invariants. Your domain code enforces invariants, things like the itinerary arrives before the minimum arrival date and leaves after the maximum departure date. And just you won't create one that doesn't. It'll throw an error if you try. Or if you try to make one that isn't connected, that goes to Dallas and then the next leg starts in Chicago. That won't happen. And this is another thing that, like the immutability, there's just so many things you don't have to think about when you're enforcing invariants like that. That's an element of domain-driven design that I like.
Yeah.
Go ahead.
We were talking about like one of the goals, and I'm sure you've heard this term too, is making bad states unrepresentable. You know, the idea of invariance saying, hey, look, you can't do this thing because the invariance won't let you is another form of like, you want to code such that you can't even represent something that doesn't make sense in your code.
Yeah. Yeah. So I've seen a lot of people in Scala in particular go to great effort to make it impossible to even compile your code if the state is invalid. And this makes it, in my opinion, a freaking nightmare to program.
I don't doubt it.
It's a game that people play with the type system, and it's a fun game. But having worked that way before, you know what? Yeah. If you just put, if this doesn't match throw, that's so much more informative. Then this type doesn't match this type, which 16 layers deep in the type definitions. Good luck figuring that out. Oh, I see it in TypeScript.
Excellent
too,
point.
And it's so painful.
Yeah.
If the error message says, look, there's nothing getting the cargo from Dallas to Chicago, then you can say, oh my gosh, there's nothing getting the cargo from Dallas to Chicago. So yeah, you need a few more tests. But I like the invariants better than struggling with the type system. Opinion. To some degree, the compiler helps, but as soon as you start getting fancy with it, have it a nice check. However,
I'm sorry, Jessica, you know me well enough to know I have lots of opinions.
Yeah, I really appreciate the interaction. That I enjoy your opinions. One thing that I do find in Scala and in like the hardcore functional programming stuff is that they're good about separating making decisions from implementing them. They can make decisions in pure code, in data in, data out code. So most of your domain code, that layer that's carefully expressed with the model is going to be making decisions. And then at some point you need the implementation details of, okay, how do I call out to the routing service? Or how do I cancel this leg on the itinerary? And that is in like an implementation layer that's in the outside of the ports and come here of the hexagon that's in this dark green stuff. How do I display this on the UI? Or transmit this to the UI. That comes out to be in a different place. And when you make the decisions and like your itinerary might return an instruction after rerouting of cancel this leg and buy a ticket on this leg. And then the implementation of canceling and buying is something else. But meanwhile, you can test whether your decisions are right, because it's very easy to test what instruction did it return, way easier than testing, did it make this call to the Stripe API? That's too far outside. You do want to test what did it decide to do. So I really like that. That's one of the big things that I pulled from my studies of serious functional programming, and it meshes with domain-driven design. But also, I mean, I've spent a lot of time preferring functional programming, even though I started with Java and OO, at least after a couple of years of C.
An attitude that does you credit.
What?
I say an attitude that does you credit, preferring functional programming.
Yeah, I mean, I get a lot out of it, but DDD, just learning about this in the last couple of years, has really brought back my appreciation for object-oriented programming. Because if you have value objects are immutable, you never change them. If you have something that does change, such as an itinerary in this case, we've recognized that we might cancel it and cancel bits of it and adjust things. An object is really, really well suited to that. In DDD, you have value objects and you have entities. Both of these contain data, but value objects, if the data changes, you just throw away and make a new one. Entities are the things that this service is responsible for. This domain is really responsible for the change in them. This is where transaction boundaries happen, and you don't want very many entities, because a value object, I don't know, you can have 6 different copies of the same leg and it all represents the same thing and nobody cares. An entity, you want exactly one. There is one itinerary for this cargo in memory and in the database, but also there's at most one in memory at a given time, so that we can keep that consistent and have transaction boundaries around changes. Don't cancel this leg unless this one, you were able to buy the new one, kind of thing. And so this brings me back to an appreciation of object-oriented programming in a couple ways. One is just the encapsulation is really good. I don't want you digging around in my legs and changing them. Let me do that because I'm maintaining invariants between them. In order to maintain those invariants, you have to have that encapsulation. It also gives you boundaries for change. I know I can change the model inside the itinerary because everyone has to access, they can only change it by calling its methods. And so I have control over that. And just keeping the idea that there are some entities, in this case, some objects, that the point is really that they can change. The job of our system is to guard them through change and guide them through change. OO is really well suited to that. Much more suited than functional programming, it turns out. So while most of my functions are going to be data in, data out, those functions might be implemented as methods on objects. It's fine. And yeah, I just find OO really good for that. Lately, I've been reading about process philosophy and how change is normal and stability is the exception. In our software, we deliberately turn that around and make everything a value object, make it immutable if we can. But change is the point. Our software is not useful if it doesn't have side effects on the world, and if what it's tracking can't change. So,
it's not, you and I have had this conversation before too, because it's not changing that's the problem. It's unintentional changing. That's the problem. When people change things without meaning to change them, that's an issue.
And without respecting the invariants that are like domain business rules.
Yeah. Accidentally changing things, that's a problem. And that's one of the reasons I prefer functional, because it makes it much harder to accidentally change things. But you have a very good point about the fact that, yeah, you do got to change some things.
Yeah, change is the point. Yeah, and I actually can really appreciate OO for that. I mean, yeah, and you can. I think it's Gary Bernhardt who long ago talked about OO on the outside, functional in the middle. But I think of it as default to functional, but you're really very important entities that you spend a lot of time thinking about often are much better as objects. And finally, I studied security last year. Finally, like got into secure development in particular, like secure code. And the biggest thing, okay, no, not the biggest. It's the second biggest thing. The biggest thing for having secure code is to update your libraries. The second biggest thing is understand your data. Really understand your data. Know what's coming in. Know what it means. Know whether pointy braces make sense in this string. Know what length of the string is unreasonable and is probably malicious. Really understand what the data means and where it comes from and what you can trust, and build those adapters and those strong boundaries and those invariants into your code so that the evil data doesn't get past them and everything that it gets into your entities and your value objects is safe. And there's this wonderful book. I love this book. If you're interested in making your code more secure, this is the book to read. Secure by Design by 3 Dans with a foreword by another Dan. And it's
or Dan's, you know it's got to be
like,
good.
It's basically like, look, if you want your code to be more secure, you need these aspects of domain-driven design. It's pretty unapologetic. Like, look, we started out writing a book about domain-driven design, but it's going to sell better if we make it about security. So here's some other stuff about security also, but just relates back to domain-driven design in so many ways, which again tells me that this paradigm really got a lot of things right. And it adds the concept of a domain primitive. In Eric Evans' books, Primitive Obsession, all the examples are using passing primitives around. And I now, 15 years later, cringe when I read that. This book makes it really explicit that you need every primitive should be wrapped in an object that names it with a domain term and enforces invariance. And then you can have a validation method on that that checks the length first, always check the length first, and then do other validations. Yeah, great book, really useful, easy to read. Has a bunch of stuff about deployment and things too, but my favorite part is the domain primitive because it's just so obviously correct and can make your code so much better. Okay. So that's domain-driven design in a nutshell through the lens of 18 other paradigms and movements. Any questions before I move on to how domain-driven design exemplifies philosophy?
Anybody speak up? I know I've been monopolizing the conversation, but that's just because I just am a shady person by nature. Please feel free to unmute yourself and speak up if you care to ask.
Sometimes it takes a while. This is fine. All right. Let me flip through these guys. Okay.
Cats got their tongues.
Hey, Ryan.
Hello.
Did you have a question?
I don't have a question right now. I just wanted to, try to encourage some people to ask Jessitron the questions.
It's fine. They're probably doing laundry. That's what I do when my video's off. Okay, so moving on, the central principle of domain-driven design is entirely this language. Eric calls it the ubiquitous language because within a bounded context, it should be in our speech, in our documents, and in our code. And you don't find this anywhere else. I don't find this in any of the other programming paradigms. The idea that we should be conscious about how we speak, and be explicit about the model that we create, and what is always true about it and what needs to be true and so on. But I do find this in philosophy. So that model that we create in domain-driven design, I mean, you can draw it as a UML diagram. You can implement it in the code. You can also draw data flow diagrams and Wardley maps and like detailed Wardley maps, and various other expressions of that model. In the end, it makes it into the code and therefore affects our users, the people who use our software. And as a result, they get the benefits of the knowledge in that model. More on that in a minute. But first of all, there's an important point about the model. The UML diagram is not the model. The code is not the model. You can make a glossary of the language, but the glossary is not the language. The language is what we use. All of these things exist in our heads. And if we're working carefully as a team and collaborating and talking amongst ourselves with the domain experts and everything, then that model will be consistent between all of our heads, approximately. More importantly, we will quickly discover the inconsistencies before they cause a problem. So that model is a thing and it exists in our heads, and we sometimes express it with diagrams, or try to, partially. And this gets into my favorite philosopher, Karl Popper. This is late Popper, when he's in like his 70s, not the stuff he got super famous for when he was like 30. And Popper has a beautiful essay about what he calls the three worlds. These are like three levels of reality, and they're all real. World one is the physical world, is like what we usually think of as obviously real stuff everyone can touch and feel. This does include things like magnetic fields, which are not like tangible, but they are stuff that everyone can experience the forces that result from them. Gravitational fields are part of the physical world, and that's in world one that we share. And then there's world two, which is the world of individual experience, which everyone has their own. This is where we feel things. This is where like the world touches us and affects our experience. You can't share this. You can't. It's your own, and it's in your head. In this sense, we are always alone. But in another sense, we're never alone. And that happens in world three. World three starts with language. And it is the concepts that we can share between people so that we can both have the same thing in our brain. You know, it's not perfect fidelity, but these shared concepts, beginning with language and continuing through things like money. Okay, is money real? I mean, you can look at like the physical representation of cash and say, well, dollar is real. But that piece of paper has no significance without the concept of money, which exists in our heads and is shared with our conventions. You can tell money is real because it has causal effects on the world. That balance in the bank account may be represented by various digits in memory on a computer somewhere. But the concept of that balance in the bank account is what has a causal effect on whether I go to the beach this summer. An effect on what is built, where, on who starves, and who goes to outer space. Money is real because it has a causal effect. And in general, world three is real. Our language is real. The concepts that we talk about here are real because they have a causal effect on the world. Time, there's another one. What is 7 p.m.? Is it a real thing? It's a world three concept, and it's causal because we all dial into this Zoom at 7 p.m. And that's you can see the causal effects of world three in the physical world. So the model is a world three object. And then we represent it in world one, things like whiteboards and diagrams and stuff. And that is, it's a philosophical concept that I find really useful, because it resolves, is this real? Yes, that thing that you're talking about, is patriarchy real? Yes. Is meritocracy real? No, but the concept is real and has real causal effects just because we believe in it. Anyway, that's a rant. So the model is a real thing shared in our heads that we then embody in the code. So this is where it becomes, our powers as a software developer are unique. Because in general, things like money have an effect on the world through people. But software has an effect on the world directly. So we put this world 3 object into the code, we express it in the code, and then the running software starts embodying our model. So the running software starts expressing bank account balances and things to people who are directly affected by them. Or maybe it's just displaying cat pictures, and that has an effect on people's experience of the world. So we like uniquely have that power to embody in software the concepts that exist in our head, and then that can have a real causal effect on the physical world, and the world of other people's experiences while we're not paying attention. It's powerful. And it says something about our products. So here's another book that I like, Why Information Grows. It's by, it's fine. It's by Cesar Hidalgo. He is a PhD in physics. He's a statistical physicist, and he's talking about information. But the key points from this book are about products. Products embody knowledge. So a pencil is a physical product, but the value of the pencil is that when I use it to write, I don't have to know how to dig up graphite or encase it in wood. All I have to know is the pencil knows how to write on paper, to make marks on paper, that is embodied in this product, and I can think about what letters to write. And this is important because just like cognitive load is our limitation in team topologies, it's the same thing again. Knowledge is our limitation in what we can do in the world. If I don't have to know how to schedule a container ship, if I can just go to the shipping company's website and say, I need to get this thing from Sydney to New York, I don't have to know all the different shipping companies in the world. I don't have to know how to schedule a container ship. I don't have to know how to get the thing on the port or the thing on the boat. All of that is embodied in the product, some of which is software that the shipping company sells. And so our software products embody the knowledge in the domain model. That's why it's so crucial to start with a domain model and get that really clear, because that is the value of our software. Not how fast it is, not even how usable it is, although that gets some stuff out of the way. The value of our software is what you don't have to know when you use the software. I don't have to know all the addresses of my family in order to send them a picture anymore. I just post it on Facebook. What you don't have to know is your power, because then we can think about bigger things. I can think about what to write instead of how to write. This is what software does for us. So this is the picture of the model embodied in the software, and then the users are getting the benefit of that knowledge.
Jessica,
yeah.
I'm going to hand it to you. I've often said to people, I think it's amusing that software developers use the term the right tool for the job when so few of us can define what exactly the job is. And you just define what the job is.
Yeah, the job is to let the users use the knowledge without having it.
Right. capture that knowledge into binary.
And now that domain, the shipping domain, very complex. We didn't mention the cases where we shipped it from Sydney to Vancouver and then it appeared in Seattle. The shipping domain is very complex. And so this domain model, I mean, I drew 3 boxes, whatever. This is just examples. This domain model gets really complex. You want that complexity. People talk about, oh, our software will be fine if we just write it simpler, make it simpler. You want this complexity. That is the value. Now, you don't want additional complexity that's just from how hard the API is to use or something. We do try to use a software as a service product to abstract that away, for instance. You can add complexity that you don't want. That's totally possible and happens every day. But the point of keeping that simple is to put more domain complexity in there. The more complexity you can handle, the more value your software can have. So if we can have clean boundaries so that we don't have to constantly keep in mind what other teams are doing, if we don't have to collaborate with them, but can instead have a customer-supplier relationship, we can put more complexity in our software. We can add more features if you want to think about it that way. And still maintain it and still be able to change it. Because at some point when you get to more complexity than a person can fit in their head, this book has a good concept of the person byte. There's only so much knowledge that a single person can hold. And when you exceed that, well, first we go to teams, but then there's a lot of overhead in working with more and more people. And once you exceed that, at some point, once you exceed what 6 people can collectively keep track of, the software just kind of ossifies. It just gets so everything you change, you break something else. And that's when the complexity goes out of hand and it gets really hard. So that's why we're constantly refining the domain model in this core domain so that we can add complexity, add features, if you want to call them that. Can you tell I don't like that word? It's fine. Without getting to that point where we can't change it. Most software in production is at that point where you can't change it. And we're just trying to cope.
That's my theory of why there's so much bad software in this world, because none of us ever come up with the simplest answer on the first pass, and we never get a second pass because none of us ever have time.
Right. We have to constantly refine the domain model in order to be able to add more use cases, add more that it can handle and still be understandable.
Yeah, and whoever gets time to go back and refactor code and refine the model and, Yeah.
And honestly, if you're in a supporting domain, whatever, just keep it running. But if you're in the core domain, you need this to be supple. Eric Evans calls it a supple design, when you find that you can handle the cargo that wound up in Seattle smoothly with like just a new method or something, and not a lot of it doesn't make the design messy. One of the challenges of all of this is that part where World 3 objects don't transfer perfectly. You could describe how a system works to someone, and they may think they understand it perfectly, but they often have a different understanding, especially if you're using the same word in different ways, which happens all the time. And that's why we have to be super, but I'll get to that in a sec. So the World 3 objects don't transfer perfectly, with one exception, and that's math. So in mathematics, we are so careful to define everything. And these things are completely abstract. They are not in the real world. They're purely in World 3. Mathematical concepts like semi-groups and integers and the real numbers and infinities. And these have strict definitions, and they are purely World 3 objects. And we can be sufficiently explicit in math to actually transfer these from one head to another. It's possible to misunderstand, but it's also possible to really get it right. And that's the only place I know of. And the reason is because they're so careful about the bounded context. When you talk about a semigroup, you know exactly what you're talking about, and then you can talk about the associativity of members of the semigroup. And you're within the context of set theory, and that's an established context, et cetera, et cetera. And that's why we have to have these bounded contexts. We cannot establish a consistent language, and we cannot transfer the domain model from one person to another except within a context. Because an itinerary for customer support means something different for tracking, means something different for the person driving the truck. We're always going to use the same words in different ways. That's fine. Draw boundaries around where something means a specific thing. And then make it mean something specific. So Karl Popper again, and this is Karl Popper, not the picture, but the philosophy, this is like Karl Popper at like 16. He noticed that arguing over definitions is useless. His dad and his intellectual buddies used to have long discussions over what is the real meaning of a word. Words don't have a real meaning in the wider world. The meaning of a word is its use, and that is always changing. However, within our bounded contexts, we can agree on specific definitions and make this like math. We can make our models transfer well, and code totally helps with that. Because in the code, we're completely precise. How does adding a leg to an itinerary work? Well, we can go look at the method and we can find out how it really works. And we can share that because we can all look at the code and we can all see it execute and we can write a test and we can find out. So we can have a precise definition of words because one, bounded context, and two, code. And this is a superpower of programming again. And this is one of the ways that programming can be like math. If we can be sure of our boundaries, we have encapsulation, so nothing is going to come modify the destination of a leg from outer space, from our perspective, from the UI directly or something dreadful. We can agree on definitions. Words can have a single meaning, and we can define them in the code and in the tests. And that's really, really valuable because we can finally communicate, which is a really good feeling within a team. Also, this is a way that the code contributes to the domain experts. So the domain experts aren't just bestowing knowledge. They are refining their knowledge. They are becoming sharper experts because of the questions we ask them that are driven by the code we're writing. We contribute to the business's understanding of itself by writing code and asking questions. So that collaboration goes both ways. And then we can put that model into the computer for other people to benefit. And so in this sense, I consider the running software to be on the team. And this is, oh no, I get to symmathesy later because it contains the model and then the users benefit from it. And this, so this is our World 3 model embodied in the software, affecting people's lives, changing how they work, changing how they ship something or buy a car or whatever real thing they're doing. And in that sense, software development is reality construction. And here's a book that I can't really recommend, but I love to read this when I'm having trouble sleeping at night. It's super old and expensive, but it's just, this is from like the 80s. A bunch of people who got this concept a long time ago, that when we build software, we're building reality. This has real effects on real people. It's not just work. And that's why we need our superpower of a custom domain language that we control within the team, that we've agreed upon within our bounded context that we defined, and it's shared. And this way we can change it, we can improve it, we can change reality. That's the point. And all of this agreeing upon words and creating a model and then embodying it in software, this is an example of participatory sense making. When we instruct this domain model, we're making sense of the world. We're making it make sense to us collectively. And then when we put that in the software, we make that world meaningful. When we practice participatory sense making. And this is a weird concept, but as humans, we do this all the time. Every conversation we have is pretty much participatory sense making, including small talk. How's the weather today? Yeah, it's pretty raining. I agree. That's how we make sense of it. That's a trivial example. But a lot of being human is interpreting the world together. It's a thing. And it's a thing that domain-driven design excels at. Here in DDD, we do this explicitly with people and the code. And collectively, we learn, and we get to be a symmathesy, which is a learning system made of learning parts. Nora Bateson coins this word in this book. And that includes us as people. We learn, the software learns because we change it. We learn from the software if we're listening to our error messages and looking at its performance and seeing how the data is changing. And our tools, because we learn from the tests and then we change the tests. All of us are learning from each other. So we're a learning system made of learning parts. And the key flow in this system is that learning, that knowledge that is our limitation is moving around and growing in this. And I think domain-driven design supports symmathesy better than any other single paradigm. The end. Yay. You can find like a reference to this talk at jessitron.com/GDD. Also, if I've motivated you to learn more about domain-driven design, Eric Evans and I are running a class in October, and you could join. It is, Tuesdays and Thursdays for 3 weeks in October.
It's awesome. Yeah, please let me know when that's going on. I would love to see.
It's right there. There's a link. You can't see the link, but if you go to domainlanguage.com,
okay,
then you'll see the link.
Where do you feel like a good entry point is in getting people like in the enterprise, right, on board with this? Or like, where do you think a good like starting point is to start talking about it with people? Because this is really, I mean, I've always loved this idea, and I've been kind of like looking at it like from afar for a few years, and I don't feel like I found like a good break-in point. Because it's like one thing to get the CEO on board, right? But then like really, unless there's some huge initiative for it, right? Like it's really having that trickle down to everybody that's going to be using it, because really you want everybody on board, right? That's going to be involved with that.
Yeah. And the enterprise-y book in this pile is Project to Product.
Okay.
That is super enterprise-y business book.
Okay.
Yeah, that's probably the one. And then for developers, I really like Marty Kagan's blog, which is also linked on that slide. But that's the one with the enterprise motivation. And
okay.
Yeah, like at Ford, they're really big on the product-driven organization thing. They've had Mick in to speak, and and that's from the top.
Okay.
Which it helps a lot to have that one from the top, because hello, you need budget changes.
Oh yeah. There's just, it's not just process. It's like there are a lot of changes even outside of or around that process, right? So
I mean, as developers, what we can do is work on the technical practices of XP, because those support that kind of change. And then XP, and also DevOps and observability.
Right.
That supports us. And we can work on creating those boundaries. And there's a lot from domain-driven design that you can do as a development team. But as an organization, the project to product speaks to that.
Yeah, it's getting like the shared language, because it's not just us, right? Like we don't want just the developers. No, otherwise we're not doing it right?
No. I mean, you can be like, we need better developers. No, you don't. No, you don't.
That, yeah.
You need a better system.
So product-driven organization, is that kind of like a methodology? Because I've never heard of that, and I'm gonna take a look at it. Or is it just kind of like a thing that
a leading
like
agile I know
Ford
publishes about product-driven organization. So I don't know how wide that phrase is used outside of Ford.
Okay.
But product teams and what's the other one? Product led, I don't know. Team Topologies talks about value stream teams, I think, which is the same thing.
That's another one. Yeah, the team topology I'm definitely going to be taking. It's probably going to be like my first. Yeah.
That's a pretty easy read too.
It seemed like it was going to be a good point to jump into it. So
yeah,
cool.
I don't remember. Well, How Information Grows is a really fun book, but there's some of the philosophy books that do not read linguistic bodies. I'm on chapter 4.
I did see that, and I'm like, whoa, that's cool, but I don't know if I'm ready right.
It's cool. There are some papers by the authors of that are closer to readable, but oh my God, that one's so many syllables. Like late at night, I'll read a few pages and then I'll read a sentence to Avdi, and Avdi's like, no, how can you read that at night?
Yeah, that sounds like one of the books where you think to yourself when you finally finish it, I did it. I finished it.
I'll probably never get there, and that's okay because I get a lot out of it. But that's a struggle.
Well, thank you. I think you gave me some really good starting points, so I appreciate that.
Cool.